Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
My dear wonderful students of Senior 3 Chemistry class, I just want to invite you to this 30-minute session of our lesson today. We will be discussing the chemical properties of alcohols and uses and their uses. That is the lesson number 3. Remember, we are still dealing with unit number 9, which is the structure, properties of alkenes and alcohols. So that is the unit we are still on, and we are still proceeding. I just want to welcome you to get ready, and we proceed with our lesson. Please, wherever you are seated, please make sure you pick your pen and paper or your notebook and put down some important information that we'll be discussing together. So under the chemical properties or the chemical behavior, we'll talk about the combustion. That is one of the first reactions that we'll discuss, combustion. So when we talk about the combustion, we had talked about this reaction even earlier before. There are two ways how the combustion takes place. We can have either complete combustion. We can have complete combustion, or incomplete combustion. They are incomplete combustion. So those are two forms of combustion that we're talking about. So that means in complete combustion, we are talking about in plentiful supply of oxygen, or in plentiful supply of air. Or when we talk about the incomplete combustion, that is less oxygen used for burning. So alcohols, this is a very important note for you. Alcohols react with oxygen to form carbon dioxide, water, and heat to form carbon dioxide. And we'll use ethanol as an example. So if we have ethanol, C2H5OH plus the oxygen, you'll get carbon dioxide gas, water, plus the heat energy. That is why ethanol is used as a source of fuel, because it can undergo complete combustion to produce that heat. That explains why ethanol is used as a source of fuel, as we'll talk about it later in the uses. So this reaction can also be included under the uses, the complete combustion. So another reaction that I want us to talk about is the reaction with metals. Reaction with metals. Reaction with metals. So this is the reaction which is similar to that of water. How does the water react with metals? I hope you know that reaction, how the water reacts with metals. So, for example, if I use water as an example, and I use sodium metal, that is one of the examples of the metal that I've chosen to use. So this reaction will produce sodium hydroxide plus the hydrogen gas, so which is effervescence. So you'll have bubbles of the gas forming, or we call it effervescence of the gas. And the gas pops when it is burnt in air. So this reaction is also similar. That is the salt and the hydrogen and the hydrogen gas that is formed. So similarly, ethanol reacts with the sodium metal to form the salt of that metal, which is sodium ethoxide. So we have C2 H5O, sodium, plus the hydrogen gas. However, the most important thing that we should note is that the reaction takes place at, it is less, the reaction is, the reaction with metals doesn't take place faster as compared to that of arc of water. So they react with metals less compared to that of water. So this is ethanol plus the sodium metal. This is sodium metal plus sodium ethoxide. Sodium ethoxide. Sodium ethoxide. That is the salt of the metal that is formed. Sodium ethoxide. So you can have as other metals, not only sodium metal. So it can even react with other metals. For example, if ethanol reacts with calcium, that is another example, with the calcium metal, so it will form the same ethoxide of the calcium. So you'll have C2H5, or then you'll have the calcium ethoxide. So you'll have the calcium ethoxide plus the hydrogen gas. Calcium ethoxide and the hydrogen gas. So that is the salt that is formed. So you need to know that reaction. So those are two reactions. Reaction with metals and the combustion. But mainly, because of the less reactivity, sodium reacts much faster than when we are talking about the calcium metal. So we can also talk about the reaction with the concentrated sulfuric acid. Do you remember that reaction? Because we had talked about this reaction, if you remember, in the preparation of alkenes. Under the preparation of alkenes, we mentioned this reaction. So this is elimination. We call it elimination or dehydration reaction. Why dehydration? Because water is removed from the ethanol. So dehydration means removing water molecules from the substance. So concentrated sulfuric acid is used as a dehydrating agent. It removes the water from substances that contains water. Even when it drops on your skin, that's what it does. If you put the water, if you put either the wood or the cloth or whatever that contains some water molecules, they will be removed. So this is called an elimination reaction, whereby ethanol will react with concentrated sulfuric acid. We can just put it on the top here with concentrated sulfuric acid. At 180 degrees Celsius, this will form a thin molecules plus the water. So water is eliminated. That is why it is called an elimination reaction or dehydration reaction. So this is ethene, and this is ethanol. Those conditions are very important when such reaction is discussed. At 180, in some other books you'll find the temperatures are between 170 to 180 degrees Celsius. So another important reaction that we want to discuss is ester formation. Ester formation. Ester formation. Esters are sweet-smelling compounds that are used in manufacturing perfumes, mainly perfumes, but there are some other substances, there are some other materials or some other homemade substances that contain these esters. So when I talk about the perfumes, I think that is something that is common and is known at least by everybody, but it's not the only use. So they are sweet-smelling compounds, and they are used when manufacturing the perfumes, different esters. And the reaction, the esters are formed when alcohols react with the carboxylic acids. Carboxylic acids are also other group of compounds or other homologous or another family of compounds that we will discuss later on about the carboxylic acids. So alcohols react with these carboxylic acids to produce those esters, which I said they are sweet-smelling compounds and mainly used in the manufacture of perfumes and deodorants or cosmetics as well. So how does the reaction take place? When we are looking at these reactions, there are certain conditions that we normally write down. And those conditions should be remembered when you are writing the conditions. These organic compounds, what you should always know is that they are less reactive. And that is why they react under specific conditions. The conditions I'm referring to is either temperature, pressure, or concentration, and catalysts sometimes. So we include the catalyst under these reactions. So it is very important to note the conditions under which the reaction takes place. Because if those conditions are absent, then the reaction won't take place. So in ester formation, we said an alcohol combined with the carboxylic acid to form the ester plus water molecules. So this esterification is also called condensation reaction because of the formation of the water molecules. But this reaction takes place under specific conditions. Concentrated sulfuric acid, and at temperatures of about 100 degrees Celsius, or you can say heat alone is enough. So those are the conditions I'm referring to and which you should not forget. So we can use any type of the alcohol. So if we use, for example, ethanol, which is the simplest alcohol, the simplest common alcohol, but we have methanol as well. So this is the simplest or the common type of alcohol that is known. Then we add carboxylic acid. We use ethanoic acid or acetic acid, which is a component of vinegar. I think everybody knows the vinegar. The main component of the vinegar is this ethanoic acid that is used in dressing salads. So it is, the main component is this acid, acetic acid, that is the common name, or ethanoic acid, according to the International Union of Pure and Applied Chemistry. So this reaction is reversible reaction. So when I put those arrows, I think you should always remember that this indicates the reversibility of the reaction. The reaction can go forward and can go backward as at the same time. So this is a reversible reaction, and it will be in equilibrium. So it will form an ester. So this is the type of the ester that will be formed. C2H5 then plus water. How do we form the water? So we said, let us get the way how these esters are formed. The simplest way of how the ester is formed from these two organic compounds. So what I can do here, let me first write the carboxylic acid, then I add this alcohol, C2H5OH, Or what I'm going to do is to reverse the alcohol. If I do it this way, I say OH, the H, this is the H, and then C2H5, if I write it in that form. So here, we'll have this OH from the carboxylic acid combining with the alcohol, or hydrogen from the alcohol, eliminating the water molecule here. So once this water is eliminated, so we are having this. So you see this skeleton of the alcohol, this is part of the alkyl group from the alcohol. That's why I'm calling it a skeleton with O, combining it with this. So you will have CH3CO, this O from the carboxylic acid, and this oxygen from the alcohol and the alcohol skeleton. So that is how we get the acid, the ester, sorry. So this is ethyl ethanoate. That is how we name that one, ethyl ethanoate. Ethyl ethanoate. So we'll come to the naming later on when we come to the carboxylic acids, because we'll have to discuss carboxylic acids in general. So we'll discuss that one. Can we use another example apart from this alcohol? Let's use another type of the alcohol. Let's use methanol as the type of the alcohol. This is the methanol, one type of the alcohol. Then plus the ethanoic acid. So we are saying, how do we get the structure of this carboxylic acid? We are just going to remove this OH from the carboxylic acid and this hydrogen combining together to form the water molecule. So we start with the skeleton of the carboxylic acid. That is what we start with. So we'll have CH3, CO, this is what I'm writing here. Then I will bring this in a reverse direction. So we'll have OCH3, then plus the water molecule. So this one will be methyl ethanoate, methyl ethanoate. So that is how we write the equation for the ester formation. We may have another reaction whereby you may have CH3 COOH plus CH3 CH2 oxygen. So this is ethanoic acid, but this is another type of, this is also another way of writing it. So instead of having C2H5, we can as well have this one. Remember, the conditions are the same. Even if I don't put them here, remember these conditions of temperature and the concentrated acid. So another reaction that we need to discuss under the alcohols is oxidation reaction. Oxidation reactions. Oxidation reactions. So we had discussed this part, what oxidation means. We have discussed what reduction means, what an oxidizing agent means, what a reducing agent means from the previous lessons. So we need this time, remember when we were discussing about electrolysis, one of our first lessons was about the reduction, oxidation, and oxidizing agent, and the reducing agent, and all that stuff. So this time, ethanol alcohols, in the presence of oxygen, can be oxidized. In the presence of oxygen, we have this oxygen written in that form. Can we move to the screen and see the reaction? In the presence of this oxygen, you see how we are writing the oxygen this time. This oxygen is not the normal oxygen of the air. It is the oxygen provided by the oxidizing agents. The oxygen provided by the oxidizing agents. What are these oxidizing agents? The oxidizing agents that we are talking about are, we have potassium dichromate over there. You have potassium dichromate and potassium permanganate. These are the oxidizing agents that we use, that they are strong oxidizing agents, and they oxidize alcohol into carboxylic acids. So this is one of the methods how these carboxylic acids are prepared. So we'll have, if you have an alcohol, which is ethanol, in presence of the oxidizing agent, this oxygen is provided by the strong oxidizing potassium dichromate, potassium permanganate. All these are the ones, they are strong oxidizing agent, and heat, the alcohol will change into the carboxylic acid, CH3COOH plus the water molecules. So any alcohol oxidized, and this is a very, very important reaction that can be used to test for the presence of the alcohol. Because the oxidizing agents, these oxidizing agents that we are talking about, either potassium dichromate, if we say potassium dichromate, this is yellow-orange. This is yellow-orange in color. And when we talk about the potassium permanganate, this is purple in color. So the most important part of this reaction is the test, how these alcohols are tested, or how can you confirm that a liquid given contains an alcohol in it. So you can just warm it with potassium dichromate. When you warm it with potassium dichromate, if the alcohol is present, it will change to green. And if it is potassium permanganate, the purple color will disappear. It will disappear. The purple color will disappear. That is if the alcohol is present in that liquid. And for that reason, this reaction is used in breathalyzers. The breathalyzers are the ones that test the amount of alcohol one has taken. So you look at the this is an example of the breathalyzer. So when you are driving and you have taken a lot of that and some alcohol, they will ask you to breathe your air into this equipment. And if you have taken some alcohol, then this alcohol, the content of the alcohol will be recorded. There are some figures that will be recorded. That means if you have gone extra, if you have taken beyond the expected, then you'll have to be taken somewhere where you'll have until the alcohol is over, and then they will ask you to go home at a later time. So what happens in those breathalyzers, there is potassium dichromate. And the reaction that takes place there, it's a bit complex. Don't mind about the complexity of the reaction. But what is important is that there is potassium dichromate that I've talked about. So when you breathe in the alcohol, if you have taken the alcohol and you have been driving, you take the alcohol, when you breathe in that equipment or that device, the reaction takes place inside there. The potassium dichromate, the alcohol will oxidize, it will get oxidized by the potassium dichromate and change it into the ethanoic acid, but with the formation of the chromium ions, which are green. So this is a redox reaction. So with the redox reaction, there is we call it, in this reaction, a chemical energy is changed into electrical energy, which produces the current that can be able to be recorded on, and change that can be able to be recorded on the machine, on that equipment that we are looking at here, in terms of the grams in the amount of the blood that you have taken. And therefore, it is very important to note that laws of driving under the influence of alcohol vary between countries. The international accepted limit of blood alcohol content before the person is charged with crime, it is about 0.05%. But in Rwanda, it is presently at 0.08%. So if you breathe in the alcohol, breathe in that device and it reads 0.08%, that means 8 parts in 100 cubic centimeters of the blood. Then you have taken excess and you'll be charged for what you have taken. So these are some of the uses of the alcohol. You can say this is ethanol. We have alcoholic drinks. We have solvents. We have fuel for vehicles. We have hand sanitizer that we have been using in many times during this time of COVID, because alcohols can dissolve the fat layer that covers that virus. I thank you so much, dear students. I hope to see you in the next lesson. Please stay safe. Have a good day, and bye-bye.